We have been talking about the distributive property. Here are a couple examples of what we've done in class. Here are two rectangles, a green and an orange rectangle, making a larger rectangle when you put them together. The dimensions of the green rectangle are 3 by 5, and the dimensions of the orange rectangle are 3 by 2. So if we wanted to find the area, we could write it as 3 times 5 plus 3 times 2. We could also write it as 3 times 5 plus 2, and just find the area of the whole rectangle all at once. You'll see if you multiply 3 times 5 and 3 times 2, you'll get 15 plus 6. And over here, you'll do your parentheses first and get 5 plus 2 is 7, and 3 times 7 is 21, so both sides equal 21. Here's another example. You might also have a rectangle that has a variable in it. So here's our rectangle with dimensions 2 by 3, and here's another rectangle that's 2 by x. So that means that the area of the first rectangle is 2 times 3, or 6, and the area of the second rectangle is 2 times x, or 2x. So 6 plus 2x. You could also write this as 2 times the quantity 3 plus x. And here you're starting to see the whoop whoop we've talked about in class. 2 times 3 is 6, and 2 times x is 2x. Finally, don't forget to put a rectangle the other direction. Somehow this seems harder for us. But here we've just flipped the rectangle. The dimensions here are 4, a variable, and 2. So you can see the pink rectangle is 2 by 4 with an area of 8. And the yellow rectangle is 4 by a, giving an area of 4a. So 4 times a is 4a, and 4 times 2 is 8. We will also be looking at just pure algebra where there's no picture involved. For example, it might say 5 times the quantity 3a plus 4. This is when you can do your whoop whoop. So imagine going whoop and then whoop, distributing that 5 on both of those terms. 5 times 3a is 15a, plus 5 times 4 is 20. Here's one where you'll do whoop, whoop, and whoop because there's 3 terms inside the parentheses. So we'll have 6 times 2a, 12a, plus 6 times 3b, 18b, plus 6 times 4c, 24c. Finally, you might have to go the other direction. That means we need to find a common factor that we can take out of each of these terms. If you look closely at this, you'll see that 5 can be divided out of both this term and this term. So if we take 5 out of 5, that is 1, because 5 times 1 is 5. And if we take 5 out of this term, 5 times 3r is 15r. That's all for now.